In this episode, we will talk about On Path to Multimodal Generalist, General Level, and General Bench. You've shared some fascinating source material with us, excerpts from a paper, and some really helpful images that gets right to the heart of what's next in AI.
Absolutely. We're looking at systems designed to handle, well, basically everything, not just text or images, but lots of different data types.
Right, these multimodal AIs, the ones
Yeah.
that can supposedly see, hear, read, understand 3D space, the works, and ideally do it all well.
That's the key word, well. Because the big question is, how do you even measure that? How do you know if an AI is truly a generalist across all these things?
Instead of just being, a collection of different tools bolted together.
Exactly. Is it truly integrated or just good at specific things in isolation? And this source material introduces a framework, a potential way to evaluate this, concepts called general level and general bench.
Okay, so our mission for this deep dive is to unpack these ideas. We
Hmm.
need to figure out why evaluating these generalist AIs is so tricky, how this new benchmark, General Bench, tries to tackle that, and what it tells us about where these advanced models actually stand today.
Sounds good. Let's get into it.
So first off, how does the source define this multimodal generalist AI? What makes it generalist?
Well, they're quite specific. It's not just about having different capabilities. It's an AI system that aims to cover a really broad range of tasks, skills, and modalities. You mentioned them.
Right.
Language, image, audio, 3D.
A broad range, okay.
And critically, they stress it needs to cover both comprehension, so understanding the input, and generation, creating new output.
Ah, right, understanding and creating.
Yes, and doing that across lots of different scenarios and domains. It's a tall order.
So it's not enough to just say understand an image. It should maybe be able to generate an image based on a description too, within that same system.
That's the ideal, yes.
Yeah.
And that really highlights the core challenge, doesn't it? Evaluating this kind of holistic capability.
It does. How do you test if it's truly generalist across everything, rather than just a patchwork of specialist skills? It feels like our current tests might miss that bigger picture.
That's exactly the problem the paper points out. Current benchmarks might test, image understanding really well or language generation,
Yeah.
but they don't necessarily capture the breadth and, importantly, the balance across all these different things.
Okay, so they might find a model is great at X, but totally miss that it's terrible at Y and Z, even though Y and Z are related.
Precisely. You don't get a sense of the overall integrated capability, and that's the gap General Bench is trying to fill.
So General Bench is the proposed solution. What
Yeah.
makes it different? What are its key features according to this source?
The paper lays out a few defining characteristics. First, it's designed for broad coverage tasks, skills, modalities, as comprehensive as possible.
Wait, breadth is number one.
Second, and this is crucial, it includes both comprehension and generation tasks, not just one or the other.
Got it. Balance again.
Third, a real focus on diversity across different domains and scenarios, trying to capture the richness of the real world.
Makes sense. Not just generic web images, maybe.
Right. And fourth, it tries to preserve the original task formats whenever possible, so it's testing skills in a realistic context. And finally, it's meant to be dynamically maintained, updated over time.
Because the field moves so fast.
Exactly. A static benchmark would be outdated almost immediately.
Okay, that scope sounds ambitious.
Yes.
Building that must be incredibly complex. How did they actually go about constructing General Bench? The source mentioned a 5-step process.
Yes, a very structured approach. Step one was all about defining the scope and range. So discussions to decide, okay, which modalities are in, which core skills they call the meta tasks, like reasoning, creativity should be tested, and what prediction types, comprehension or generation.
Laying the groundwork first. Makes sense.
That sets the whole foundation. Then comes sourcing the actual data.
Right. Where did the test questions, the images, the audio clips actually come from?
They describe two main ways, case A and case B. Case A is about using existing known benchmark datasets, but, and this is important, they only use the test sets from those benchmarks.
Ah, not the training data the models might have already seen.
Exactly. And to add diversity and prevent simple memorization, they modify these test items. So for text, they might use something like ChatGPT to rephrase questions or prompts. For images or audio, maybe find similar but distinct examples.
Clever. So, adapting existing tests. What if there isn't a good existing test for something they need, like maybe a new type of 3D task?
That's case B. If existing datasets aren't good enough or don't exist for a needed area, they basically create new test instances manually
Wow, from scratch.
from scratch, crafting the input, the expected output based on the task definition. They might even use existing models to generate a first draft of an output, but then humans have to manually check and correct everything.
That sounds like a ton of work. Manual verification?
It is, but it's probably necessary for ensuring quality, especially for novel tasks. Which leads to the final step. Step 5, validation.
How do they make sure the data they've collected or created is actually good?
Rigorously. They use groups of 3 annotators. Each test instance gets reviewed independently by all 3.
Okay.
And it only gets accepted into general bench if all 3 annotators agree. There has to be consensus.
Unanimous agreement.
Yes.
Yeah.
And even then, team leaders do a final check to ensure consistency and quality across the board.
That's some serious quality control. Seems appropriate given the goal. Okay, let's move from the how to the what. What kinds of tasks are actually in general bench? The source materials show a huge variety.
It's incredibly diverse. Just looking at images, for comprehension, you've got things like standard image captioning, object detection. The example showed identifying things in a traffic scene, depth estimation, scene graph parsing.
What's scene graph parsing again?
It's about understanding the relationships between objects in an image, like person riding bicycle on road, not just listing the object.
Got it. Relationships.
Then there's visual question answering, VQA. Answer questions about an image. And they have general VQA, but also specialized types like art VQA, medical VQA, maybe finding an abnormal heartbeat in a medical scan image, and even image similarity VQA.
So really digging into different kinds of image understanding. What about creating images? Generation.
On the generation side, they include tasks like image-to-image translation. The example was turning a Van Gogh-style painting into a similar scene, but with roses instead of sunflowers.
Ah, okay. Manipulating and generating new visuals. How about video and audio, things that happen over time?
For video, you see tasks like video action recognition, like recognizing sign language, video question answer, asking about what happened in a clip, like character outfits, video object segmentation, detecting actions over time like someone hugging, and even things like business video captioning.
And audio.
Audio comprehension includes audio question answering, like figuring out what event caused a sound music understanding, speech understanding, and speech emotion understanding, recognizing if someone sounds happy, sad, angry.
And generating audio, like text-to-speech.
Exactly. Text-to-speech, or TTS, is in there, plus audio editing, transferring speech styles, and even music synthesis.
Wow. And 3D is covered, too.
Yep. 3D comprehension tasks like 3D object detection, 3D question answering, analyzing 3D motion, and creating a 3D mesh from an image or generating 3D motion from text.
It really covers the senses. But you mentioned earlier these link back to broader skills or meta tasks.
Right. It's not just about the modality. The tasks are designed to probe deeper skills. Things like math problem solving, you see examples like age word problems or geometry problems presented visually.
Math from an image, okay.
Code problem solving, like explaining what a piece of code does. Core natural language processing skills like text entailment, sentiment classification, named entity recognition, or NER.
NER, finding names, places, etc.
Yes, but not just general ones. Also domain-specific NER, like identifying diseases or terms related to climate change. Also relation extraction, or E, like finding mentions of adverse drug reactions in text. Event extraction, too.
So extracting structured information.
Exactly. And importantly, it's multilingual. Tasks like neural translation, multilingual QA, the example showed Catalan. All these feed into evaluating those broader meta tasks. Content recognition, reasoning, common sense knowledge, even creativity.
That is incredibly comprehensive. It really hammers home the generalist idea. But okay, you have all these tasks. How do you actually score an AI to say if it's a good generalist? Not just good at parts, that's where this general level score comes in, specifically level 4.
Precisely. The general level 4 score, or S4, is the key mechanism for evaluating that balance. The whole point is to measure how well a model performs across both comprehension and generation tasks within a given skill or domain.
Not just looking at the best score it gets in either area.
Right. It's designed to avoid rewarding a model that's, say, amazing at understanding images but completely useless at generating them, even if that understanding score is world-class.
Okay, how does it do that? The source had a mathematical example.
Yeah, it's quite neat. Imagine you have 2 models, A and B. They're tested on a domain with, say, M comprehension tasks and N generation tasks.
Okay.
Model A, ACE's comprehension, gets X tasks right, but BOM's generation only gets Y tasks right. Let's say X is much bigger than Y, so its scores are XM and YN.
Specialist model. Great comprehension, poor generation.
Exactly. Now, Model B is more balanced. It gets, say, X tasks right in comprehension and X tasks right in generation. So its scores are XM and XN. Maybe its generation score isn't as high as Model A's comprehension score, but it's balanced. Okay, Model B is the generalist here, even if not peaky.
Right, and the formula they use for the S4 score, it looks a bit like a harmonic mean. Emphasizing the lower score is set up so that Model B, the balanced one, ends up with a higher overall S4 score than Model A, the uneven one.
Ah, so the math itself penalizes that imbalance. Precisely. Even if Model A has a single very high score, its low score drags down the overall S4. The formula directly rewards models that perform well across both sides of the coin, comprehension and generation, for that skill area. It reflects the goal, finding generalists.
That's a critical piece. The scoring has to match the philosophy. So they built this benchmark, they have this scoring system. What did they find when they actually used it to evaluate current models? There is an observation 3 mentioned.
Yes, some really interesting findings. They looked at well-known large multimodal models, MLLMs, like GPT-4v and the newer GPT-4o.
What did they find out about them?
Well, these models perform strongly, sometimes even matching or beating state-of-the-art or SOTA specialist models in certain areas. Particularly, they showed really impressive capabilities in image comprehension.
Okay, good at understanding images.
Very good. However, the paper points out a stark contrast. These same models offer very limited or sometimes even zero support for the corresponding image generation tasks within the general bench framework.
Ah, so that imbalance the S4 score targets. They saw it in action with major models. Strong comprehension, weak or non-existent generation in the same modality.
Exactly. Despite the multimodal label, the capabilities were very uneven, at least according to this evaluation.
And what about language? These models are often built on top of large language models. Did they ace the language tasks in General Bench?
That was another key finding. Surprisingly, no. The evaluation showed that these MLLMs, despite their language model core, didn't actually surpass the state-of-the-art language specialist models on the core language tasks included in the benchmark.
Huh. That seems backwards. You'd think adding vision or audio might help language, or at least not hurt it. Any idea why?
The authors offer a hypothesis. They suggest that the intense focus needed to train and fine-tune these models on all the non-language data, the images, the audio, etc., might actually come at a cost.
A trade-off.
Potentially. It suggested this multimodal training could inadvertently weaken their core language abilities. So adding multimodality doesn't necessarily boost language skills and might even dilute them somewhat.
Wow, that's a really important point. The path to adding more senses might mean sacrificing some depth in the original one. That has big implications for future AI design.
Definitely raises questions about architecture and training strategies.
Now, building something like this, a benchmark that pushes the boundaries, also involves ethical considerations. Did the paper touch on how they approach that?
Yes, they did. They outlined an ethical framework. A major focus was privacy and data protection. They explicitly worked to exclude personally identifiable information, or PII.
PII, like names, addresses.
Exactly. Anything that could identify a specific person. They also anonymized public data where needed and aimed for compliance with regulations like GDPR in Europe and CCPA in California.
Okay, protecting user privacy was key?
Yeah.
What about the data sources themselves?
They focused on using publicly available resources, or data, where contributors gave explicit consent. Transparency was important, making sure people understood how their data might be used and what rights they had.
And the people doing the work, the annotators rating the data.
Annotator compensation was mentioned. They stated a commitment to fair pay for the trained annotators and any crowdsourced workers involved in building and validating the benchmark.
Good. Recognizing the human effort. What about bias? AI bias is a huge topic.
They acknowledge it. They know biases related to gender, ethnicity, language, and so on can creep into large data sets. They said they took active steps to analyze and try to mitigate these biases using diverse data sources across modalities and languages.
But they also acknowledged it's hard to eliminate completely.
Yes, they were realistic, calling it an ongoing challenge, but emphasized it was an active effort.
That sounds like a responsible approach. Anything else on the ethics front?
Intellectual property, or IP. They stressed respecting IP rights, making sure they used external data under the correct licenses, and complying with model licenses and API terms when evaluating different AIs. No misuse of proprietary stuff.
Okay, so a pretty thorough ethical checklist alongside the technical design.
It seems they tried to cover the bases, which is important for a benchmark that aims to be influential.
So wrapping this up, what does this all mean for you listening in? It seems pretty clear that Evaluating these really ambitious, generalist, multimodal AIs isn't simple. It's not just about checking off boxes on individual skills.
Definitely not. You need something comprehensive like General Bench that really tries to span the huge range of tasks, data types, and abilities.
And maybe even more importantly, you need a way to score them, like the general level score, that specifically rewards balance. How well does the AI handle both understanding and creating across the board, not just rewarding isolated peaks of brilliance?
Right. And the initial findings using this approach are quite revealing. Even the leading models today show this significant unevenness, often strong on comprehension, weaker on generation for things like images. And they haven't quite achieved that seamless generalist capability yet.
Plus, that fascinating hint that maybe, just maybe, becoming multimodal right now involves trade offs, potentially weakening core strengths like language.
It raises a fundamental question as these models get more complex. Will we always face this tension between being a deep specialist versus a broad generalist? Or can future AI architectures find a way to achieve both depth and breadth simultaneously?
That's the big question, isn't it? Something to definitely keep an eye on as you watch this space evolve.